This is Dave Hammer, an amateur blacksmith, with something to share with you today. I'm going to make this hot cut, small hot cut. It's only about 4 inches long and maybe just a little over 3/4 inches wide. The source material is a piece of S7, a drop from a machine shop. The first thing we need to do is to square off the ends and get any extra stuff that's on there. We don't want anything that gets folded in that might give us cold shuts later during our forging. A little bit more on that end. This is my Super C forge. If you are aware of my other YouTube videos, you should have seen how this is built and lined. It takes just a few minutes. It would be better if the forge was hot before I put that in there, but it's warmed up a little bit. The inside of that forge ends up totally a glowing yellow, which would be the most efficient heat burn chamber. We're going to forge that 1 1/4 inch round down to a 3/4 square. And this is S7, and yes, it's difficult to forge. I'm using rather large hammers to do this. That's probably a 4.5 pound hammer, maybe more. Some of these clips, portions of these clips in here are speeded up to 3 times just so I don't so I could have the video a little bit shorter. And also, you are not seeing all the forging. You are seeing a strong representation of the forging, all the forging, but not all of it. S7 moves slowly. It's impact resistant, shock resistant. It's a tough steel. It's actually only a little bit above a medium amount of carbon in it, about 0.55. Next, we're going to punch that hole. This is our tool set: a pail of lube, a heavy hammer, and a punch drift. That's it, drift, about 5/8 of an inch wide and 3/16 of an inch the other way. Line up about just a little less than a 1/2 inch from the end, and I punch from one side until I feel the anvil. You can very definitely feel it. And then I finish from the other side. It pushes out a little pig. You don't see that in this video, but I push that out over the hardy hole and it flies out. So it's like a little biscuit that flies off to the side. You just want to be sure you don't step on it. That's the slot punch hole. Next is to widen that hole with the same tool being used as a drift. It's punch drift is something I made and then tapered the sides up to be useful as a eye drift. That's the hole. Next, we taper that from forward the eye down. We're going to use a blacksmith magician to narrow the cross section just in front of the eye. I just hold it in, I push it against the eye. Use about an 8 pound sledge to hit it. You need to hit it and turn it a few times. This takes a couple heats. I need to make my magician so it stays in one place on the anvil. That would just mean welding a post on the bottom that goes into the hardy hole. There you can see the narrowing. Next, then the taper from that narrowed area down to about, as I keep saying, about 1/4 of an inch or maybe a little less than that. This again takes numerous heats because this tool steel is difficult to forge. Not impossible. I've made several of these on using a power hammer. It only takes it takes a lot less time. But I wanted this video to be hand forging. I use the edge of the anvil and I use the horn. Oops. As you're forging, it's going to spread both ways. Mostly, if you're good at forging, mostly it'll spread the way you want it, but it will spread the other way a little bit. You have to true that out. After it's the taper is close, I'll clean it up with a smaller, lighter forging hammer and straighten it out. I'll go back and I'll true up and widen the eye a little bit more for a handle. We're going to make the handle, so the eye doesn't have to be an exact size to fit a commercial handle. You could, obviously. You want to put the drift in from every side, and it'll help true it up. Then just finish cleaning it up and make sure everything's in the right place. Then the only heat treating we do this is to normalize it. This says 7. And we do that twice. We do it once now and we do it after we grind. So we just heat it up to non-magnetic, use something to test magnetic properties, and then take it out and put it on a brick. Don't put it on the anvil or on metal. You want to put it on something that won't conduct heat quickly away from it. This is hardwood maple, where this handle is about a foot long total, and it starts out about 1 inch square. Just take this, true it up a little bit, take the slivers off of it. This is a 3x132 grinder. Then I'll take, I draw the eye profile on the end. The Hotcut was still about 300 degrees here, so I couldn't hold up my hand. That's what it would look like. This is all done freehand. This is probably a 60 grit belt on here. So we're shaping for the Hotcut eye right now. I get it close. Then I start shaping the handle, the rest of the handle. Just grind it down. Keep going across. This is up on the slack area of the belt. It makes it easier to do. This handle could be ground a little thinner in the center. I may yet do that. Doing sanding with wood creates the sawdust, and since I'm grinding metal on here, creating sparks all the time, this sawdust has to be all cleaned up and moved away. It's explosive. I could have a fire, I could have an explosion, so I'm very meticulous about after I work on a handle or something, I clean that up. The next thing is to fit the handle to the eye. There's just a little adjustment. I sand it down until the Hotcut will slide down about halfway on that. And if this was a regular hammer, that handle would be, there would be a wedge going in the top. Since it's a Hotcut, that stays kind of loose. I don't make it solid. Next is to square up the end, the struck end of the Hotcut. This is very important. Get this square and then crown it and dress it the same way you would a crowned forging hammer. You want to make it square and then relieve the edges and crown it a little bit. This is just a little bit of cosmetic here. cosmetic grinding. It wouldn't have to be done. This was forged very close to the finish. Something I forgot to do is put my mark on that tool. You should put your mark, your name, or a mark that identifies you on everything you make. Be proud of what you do. I'm grinding the cutting edge. This is ground down to about almost a point, but you'll see in a minute that I don't leave it sharp. Take it over to probably a 120 sanding belt, and I do the final grinding on that. When I'm grinding, when I'm sharpening a tool like this, a cutting tool, I'm rocking it back and forth. What that does is it gives you a little curvature. Now there you saw me hit the end. That's dulling that end. You don't want that end to be sharp. It should be dulled down to about 30-second. The reason for this is so when you hit metal with it, it doesn't curl over. Next we normalize again. Let it cool on a brick. Normalizing again is just heating it up to non-magnetic and then letting it soak for just a little bit and then taking it out and let it cool in the free air. Put the handle in. That was loose about halfway down. I'm just pushing it down a little bit further. We don't make this a totally solid hard connection because when we hit that struck end with a hammer, it's better that it is not super tight. This test is hitting a cold, mild steel bar, and I'm hitting that fairly hard, not super hard, and I'm seeing, and this is in lieu of or instead of using a chisel to see if that metal on the cutting edge would skate, a file would skate, and if I can hit that several times and not damage that end, it tells me that I have a good tool. Next, I'm going to take a piece of 1 inch wide, 1.5 inch thick mild steel and cut a slot in the end, about 2.5 inches long. I'm going to do most of it directly on the anvil. I should be using lube here. It just helps. Lubricant. You don't have to use lube, but it does help. It's more useful actually when you're drifting something, so that the drift doesn't stick. I'll cut this, like I said, almost all the way through down to within about I don't know, 1/16 of an inch. Again, I can feel the anvil. I could easily cut through. If I did cut all the way through to the anvil, it would damage my cutting edge because that anvil surface is a lot tougher. It's a lot harder than my hot cut, and it would damage my hot cut. We're going to see here I have a cutting plate. So I'm going to cut all the way through. My chisel is hitting that cutting plate. For the visual on this, I should have split that end apart a little bit, but I didn't. But I could see that it was cut all the way through. Half-inch steel. The final demonstration with hot cut is going to be cut the end off. It's going to be cut upwind of the slit. This hot cut has shown no distress for what I've been doing with it on the end. I've cut down probably to within almost 1/8 of an inch, and there you go. Just a couple whacks and that's done. I got a nice, actually a pretty nice square cut there. You can see that's cut through. It's a nice tool. There we go. I haven't polished that yet, but thanks for watching. I'm Dave Hammer.